Hello everyone. So today we are going to look at another basic mathematics question to find prime factors of a number. Alright. So in the previous video we saw how to find a prime factor, right? And what is a prime number. Alright. Now see here. Let's start with this example here. Input is what? 12, right? So what would be the prime factors of this number? So to brush up your memory, let me tell you about prime factors. So prime factors are the factors of a divisor, which in this case here input is the divisor, which is 12, and the factors of this number which are prime, right? Yes, all right. So what would be the prime factors of this number? 2 is going to be a prime factor, 2 is again going to be a prime factor, and then 3 is going to be a prime factor. So in basic elementary school level, what we used to do was we'll divide the number, right? 6, we'll divide the number again, we'll get 3, then we'll divide 3 and then we'll get 1. And this is the prime factorization of this number, right? And this is what we have to find. Suppose input is 315, right? Then what? Let's divide by 7. Yes, then let's divide it by 5. Yes, let's divide by 3, and we'll then again divide it by 3 and we'll get 1. Alright, so this is what we have to find. Right, hence our output is this. Alright, now pause this video and try to find a solution for this. Okay, now I hope you must have tried a solution. So let's talk about it. So there are basically two ideas of the solution. First, that divisor will always appear in pair, right? For suppose 30, this is thing. So we can say that x is less than equal to n and square root, right? We talked about this in the prime checker video, right? And then we are going to say that number can be expressed as multiplication of powers of prime factor, which we saw here, right? And you can see it here also. Okay, 12 is 2 into 2 into 3, 450 is 2 into 3 into 3 into 5 into 5. Right. Now I have seen the idea which we are going to use in the solution. So try to find the algorithm on your own. So the algorithm would work like that. We'll have a loop where we'll declare a iterator I, which will run from 2 till root of square root of n till this number, because divisors always appear in pair, and this is how we'll find a prime number, which will, if there is a prime factor of a number which will divide it, so we'll find it in under root n time in under root n, right? Okay, then what you're gonna do is you're gonna divide it. You're gonna divide n or the number as long as it gets divided. Okay, as you can see, 12 is first, our first prime number which will divide it is going to be 2, right? 12 will divide 2, 12 will now become what? 6. You can see that 2 will again divide it, so we'll again divide it by 2, it will come out to be 3, and then we'll divide it by 3, right? In the same way we are going to do for 450. We're going to divide it by 2, right? It will become 225. We'll divide it by 3. It will again get divided by 3. Then we'll divide it by 5, and it will again get divided by 5. And that's how we'll find it, right? Now let's try doing a dry run for it. So first our I would be what? 2. So we'll gonna print 2. Then we are going to divide 450 by 2. Now n is going to be 450 by 2, which is 225. Alright. Now and we can see that 225 will not divide by 2. Now alright. Now what we are going to do is we'll put I as 3. Alright. So what we are going to do is we are going to print 3, and we are going to divide 225 by 3, which is going to be 35, sorry, 75. Yes. And then we'll check if 75 will get divided by 3 again. Yes, it will. It will come out to be 25. Right. Now we're going to take I4. We can see that it will not divide 25. Hence we'll skip this. We'll go to I5. Then we can see that 25 will get divided by 5. Hence we'll print 5. Now our 25 by 5 becomes 5, sorry. Yes. Now we'll again print 5, and then we'll divide 5 by 5, which is going to be 1. Hence this is going to be the correct output, right? So this is the algorithm which we are going to do for this problem. So let's try and code it. Alright. Let's include the header file first. Let's have a main function where we'll have the divisor. It will be a user-defined divisor. And then we are going to call a function print prime, which will print all the numbers. Now let's make the parameter is going to be user-defined input. Alright. So first see if n is equal to 1, what we are going to do is cout invalid, right? Because see, n is not a prime number, so or n is n won't be having any prime divisor, right? You can see that it's common sense. So now we'll have a loop here where we have I as 2. We'll run it for till here, right? Till root n. And now what I'm saying is while n, if we okay, this sentence means what? That I is a prime factor of a number, right? If it is, equal to 0, we are going to do what? C out I. Let's have a break in every prime divisor, and now we are going to change n as n divided by I, right? So this is the idea, like, which, see, suppose I is 3, so we can see that 225 will get divided by 3, so we printed 3 first. Now what we did is we changed n to n by I. It becomes 75, and then we have a while loop. So we'll see that n, which is now our 75, is again getting divided by 3. So we'll print 3, right? So this is how we are proceeding with this loop, right? So that's how this program is going to run, right? Now suppose n is 13. Right, a prime number. What would be the prime factors of a prime number? The number itself, right? The number itself. So for that, we'll simply use the loop. If n is greater than 1, we are simply going to see out n. Alright. Now, if you are having a little bit confusion about this thing, I'll make it clear to you. Okay. Suppose n is a prime number. 101. It is a prime number. Yes. So for this, we are going to use loop till 101 root. We can say like roughly to 10. Right. Since it is a prime number, there would be no prime factors of this number, right? So till 2, 2 to 10, there is not going to be a prime factor of this number. Hence, our n would be unaltered and it is going to be only this. So we just said that if n is greater than 1, we're just going to print that number. Okay, so that is how this code is going to work, right? Now let's try to run it for a solution. Suppose 450, right? User input is 450. Okay. I guess we're printing something. Oh yes, sorry, my bad. This loop you can see is going to be outside this, right? Yes. Now let's run it for 450. See, 23355. That was the required output. Yes, let's try and do it for suppose 12. 223. Yeah. See, that is the solution here. So I hope you got it clear that what is prime factors and how to find a prime factor of a number through program. All right. So I'll end this lecture for today and see you next time.